Welcome to the Global Connection, a Tel Aviv University podcast. Journey with us as we discover how TAU's academic community and friends are engaging with and helping to shape this ever-changing world.
Hello, everyone. Welcome to the Global Connection. I'm your host today, Orit Coty, and I'm a member of the Lowy International School. Today, I'm excited to have Dr. Sagi Jaffe-Dax joining me. Sagi works here at Tel Aviv University, and he is a faculty member in the School of Psychological Sciences. He's also a researcher with the Sagol School of Neuroscience and the head of the Cognitive Development Lab. Sagi's work focuses on developmental cognitive neuroscience. Did I say that right?
Yeah.
And he also happens to be the new head of International MSc program in neuroscience. Welcome, Sagi.
Thank you. It's a pleasure to be here.
Great. So we're here today to chat a little bit about the world of neuroscience and specifically what neuroscience tells us about how the brain develops at an early age. So I'd like to begin by you just explaining to us in layman's terms, what is the field of neuroscience about?
Well, the field of neuroscience is pretty broad. I mean, people study usually people think of various models of neuroscience. So people's work usually focus on single models or a few models. It can be an animal model or computational models and stuff like that. The idea is to try and understand what the brain does and how it operates and how it achieves the goals of us as humans. Specifically in developmental cognitive neuroscience, what the field used to be is to use kids and babies as, again, models for understanding cognition, where the goal was to understand adult cognition. I have a slightly different view of that field. I think that kids are people as they are, and not future people or people to be. So they're not models of cognition, but they're actually the subject itself.
That actually sounds extremely fascinating, and we will get to that in the later part of our discussion. It's funny, when I was reading a little bit about the history of neuroscience, I actually realized that interest and research in the connection between the mind and the body started in ancient Egyptian times and Greek times. They were very interested centuries ago into understanding the mind. So we're not the first ones in the 20th, 21st
Oh, we're
century.
definitely not the first one.
Yeah.
No, it gained a lot of interest in the last few decades because we have new tools.
The technology.
That allow us to better image whatever goes in the brain, whatever happens in the brain. But yeah, the idea of asking what the brain does and what does it mean to think and what does it mean to be human is not new.
Yeah. And even though we started so many years ago, we probably have so many more years ahead of us. Right. So how did you personally become interested in neuroscience in the field?
I don't know. It just came to be. I started to study when I first got to academia. When I first started in academia, I started to study cognition or cognitive sciences, and from there, I guess the methods and the let's say methodology of studying the brain itself seemed appealing to me. Most of my PhD work was done with adults with dyslexia and adults with autism and neurotypical adults, obviously. I really like the idea that I can tell something about the brain that is not apparent straight away just by looking at behavior. We can, with these new tools, with these new exciting tools, flashy technologies, we can look deeper and try and understand whatever's going in the underlying basis of behavior.
So let's delve into that a little bit more. What are the key things that you're looking for from a neuroscience perspective in childhood development, early childhood?
So I'm trying to understand what happens to the brain when we grow from babies to being children, to becoming children and eventually adults. What changes? Obviously, we operate on a different scales and different goals. If you think of babies and children, they're amazing learners, right? But they're very poor behaviors, let's say. Their ability to perform in the outside world is very limited. The ability to express themselves. But on the other hand, they learn really, really quickly. And they learn, I mean, they don't not only learn language, which is the first thing that comes to mind. They learn to walk, they learn to run, they learn to swim, they learn to ride bicycles. And I mean, all these things would have been really difficult for adults to learn if they had to do it from scratch.
Yes.
So somehow it seems like the brain is doing something totally different when we're babies and kids,
Right.
compared to when we're adults. And I'm intrigued to see what is different in the brain.
And taking that and taking into consideration environmental or genetic factors or cultural factors, is that something that you also look into in terms of, how a child would develop here in Israel versus somewhere in China or India?
So interesting, yeah. And I'm trying to examine these cultural factors as, let's say, tools or prisms into cognitions. For example, we have a joint research with a collaborator in the U.S. where we look at the precursors of reading in pre-reading ages. So with 2-year-olds and 3-year-olds, they were exposed to text to a certain extent. I mean, kids are getting somewhat exposure to text when they walk around the street, when their parents read their bedtime story, when they look at TV, for example, and see the subtitles, they see text.
Right.
And we think that even with that little exposure before they even being started to being taught to read, they already have some attentional biases towards certain text and versus others, familiar text versus unfamiliar text, for example, and something that we can easily compare in Israel, which is kind of unique worldwide, is the direction of text, right? So we expect kids, even before being taught how to read, they're going to allocate their attention differently to different sides.
Absolutely. I myself, as an English speaker here, but living here for 20 years, if a sign is in English versus Hebrew, of course my eyes will still
Right.
go to the English.
They still go to the English,
Of course.
right? So even if so, it's in Hebrew. This will hamper your reading speed, right? Because you jump straight ahead to the end of the sentence.
Exactly. It's almost like this could be a far stretch, but it's kind of like if AI is now the thing we're talking about, kind of like the children are sort of like a built-in AI product that are constantly learning, a learning machine in a way.
Yeah, but it seems like they have a different goal. So it's not exactly the same machine when we're kids and when we're adults. It seems like the goal that this machine tries to achieve is different.
Yes, yeah.
Right?
And what is that goal?
So, for example, if we look at the age of between 1 and 2, right? Kids in that certain age range boost their vocabulary from almost 0 to hundreds of words by the age of 2.
Amazing.
It means they devoted a very large, and adults obviously can't do that.
No.
So they devoted a very large percentage of the resources, of the cognitive resources, to do that, right? To gain and to increase their vocabulary.
Right. It's incredible.
And we're adults. If we think of us being a certain machine, our machine doesn't do that anymore when we grow up.
Right. Right.
So it's almost as if the machine is devoted a different goal.
Right. So I think this kind of touches upon what we're talking about now because, the Sagol School of Neuroscience is also classified as a multidisciplinary research center. And, TAU in and of itself is very characteristic as being interdisciplinary as well. But specifically when it comes to the neuroscience field, how does that interdisciplinary setup that make it so unique, and how does it support your research?
So, I can speak of Sagol. It's a very big school, right? We have, I don't know how many, dozens, maybe even more labs. Each lab is devoted to a certain topic or to a certain model of cognition, as I mentioned. So it's very multidisciplinary in that sense. It's also interdisciplinary because we're all in the same campus, or at least most of us are in the same campus, so we meet more often than other schools of neuroscience out there in the world where they're more, let's say, spread out in different campuses around the city. Right. So just as a prosaic example, we meet at the same cafeteria almost every day. We teach the same students. So a student that sits in my class also is being also taught in the biology department and in the medicine department and in various and the student meets principal investigators from all around the campus and from all around from multiple disciplines.
That's super valuable, very advantageous. Is there are there similar setups like this in other institutions? Do they that focus on neuroscience? Do they usually work like that, or?
Yeah, so it's usually, I think it's more spread out, right? There are other schools of neuroscience in Israel and around the world, but it's usually more spread out, and it's usually not all of us in the same campus.
Interesting.
Which is kind of unique.
Absolutely. So we're going to jump into the Center for Cognitive Development, which you are the head of. Tell me a little bit about that, how it was set up. It's quite recent.
So we started 3 years ago. It's a center that is devoted to developmental cognitive neuroscience. We have a facility to accommodate kids and babies who come here to participate in experiments.
And I was going to ask you, what is the typical age range?
Any age.
Any age.
Yeah, we have experiments that start at 1.5 months, and we go all the way up to older kids, students. We do every age.
Every age.
And we have the facility to do that with every age. We can measure behavior using eye tracker. And we have gaze contingent experiments where the babies control the things that they see on the screen. We have neuroimaging techniques that is designed and devoted to babies. It's called FNIRS.
Do you need to have the baby in a certain state of calmness, or it can work in any situation because kids are unpredictable?
Yeah, kids are unpredictable. Sometimes it works, sometimes it doesn't. We go along with them if they need extra time to rest or to eat or to change. We have a changing table. We have a nursing station. We have everything they need. There's a little gymboree if the older kids need some playtime before we start the experiment.
Wow.
We can accommodate for a lot of things. We have coffee machines for mothers if they need that.
So it's almost a kindergarten, but just a little different.
Right, for a single family each time.
Exactly. So what would you say would be some of the interesting, most points of research that stand out to you, and how do they kind of connect to the other research in this field in the wider world? So
there's, I don't know, I can think of many examples, but maybe one of them that we recently saw the preliminary results a few minutes ago from a pilot study that we ran. The student wanted to ask whether kids can locate sound before they can move their muscles towards that sound, right? I mean, on one hand, why would they? I mean, if they can't do anything with it, they can't move their head towards that source of sound, then maybe they don't need that computation to happen. On the other hand, something needs to be built gradually towards that stage where they can shift their gaze and shift their head towards that source of sound. So it was an open question until the student came up with the idea of how to test it. So we're looking at 1-month-old, 2-month-olds, and 3-month-old babies. And the student basically reads a story to them. Wow. These babies at this age, they can't even focus on a screen yet. So there's no point in doing a really controlled experiment on a screen, right, as most experiments are being done. So the student reads a story to them, and she uses this monkey, stuffed monkey, which makes sounds. And sometimes the monkey is on the right side, and sometimes it's on the left side. And the monkey makes sounds during the story. The monkey itself doesn't make the sound. There are speakers behind the student, and sometimes the sound comes from the same direction as the monkey, but sometimes it comes from the other direction, right? And we want to see whether the baby's brain can detect this mismatch between vision and audition, right? Between the place where they see the monkey and the place where the sound is coming from. And if the brain manages to detect this mismatch between those two sources, then it means that it computed the direction of the sound, or the direction where the sound came from.
Wow, that's fascinating, really.
So it was a pretty simple,
yes,
but clever design that the student came up with.
Yes. And are there any other general trends that you would say are something to look for in the world of neuroscience today?
Well, every year there's a new technology that comes up. There's a new neuroimaging technology, a new computational model. One of the courses that I teach is computational models of cognition. So I used to have to explain to the students why we need to understand these computational models and what their potential could be. But then 2 years ago, all this explanation became unnecessary, right? People just saw what ChatGPT can do, and all of a sudden, no need to explain. Just teach us how these models work. We know it's important. So, yeah, things change all the time. It's good to sit on our edges and to look for new technologies and new ways of thinking and new models.
Absolutely.
I don't know, it's a fascinating field, I think.
It really is. It really is. So that brings us to the International MSc program in neuroscience here at TAU. You've recently become the head of it, so congratulations.
Thanks.
What makes this program unique, and tell us a little bit about it?
So I'm kind of new to the program, so I'm still learning about it. This program is unique because I think it allows students to choose from a very large variety of laboratories and research groups. On one hand, on the other hand, you don't have to commit yourself only to a certain field. You can choose from even if you chose one laboratory, you can still choose from a very large variety of courses, right, or modules that you can take from all around the campus.
And the program is 2 years, right?
Yeah.
And entirely taught in English.
Yeah.
With a thesis.
Yeah.
Option. Yeah. So, why would you recommend a student to specialize in neuroscience today?
I think it's interesting. I mean, I think it's an interesting field, and it opens avenues to various directions of let's say professional development. I think anywhere in industry and in academia, this breadth of knowledge is appreciated, and the ways that you learn how to deal with high dimensional data and non-trivial representation of data, and the way that we ask questions is kind of unique, because you can ask the same question in multiple ways and come up with the experimental or research design in multiple ways. So it's a very wide wide field of knowledge.
And the fact that
and skills.
It is interdisciplinary. It means that there's a wide range of types of people that can apply with different backgrounds as well,
right.
which I think adds a lot to the output of it and the experience of the cohorts themselves as well.
Yeah.
Okay. So from my understanding, you can apply for the program until through March the 20th through the international Lowy websites. For those listening, what kind of student are you looking for, Sagi?
We're looking for curious people. We're looking for people who are keen to learn and to examine their knowledge critically and in ways that they haven't thought about before. We're looking for, obviously, we need diligent and talented people. And yeah, I mean, when I meet students, I'm more interested to know what interests them and what questions they have about the world.
Yeah, I think that's a good start in describing everything, and it's a good way to end on this note. So thank you for joining us. It's been an absolute pleasure, Sagi.
Yeah, it was a pleasure.
Wish you luck in the new position.
Thank you.
Okay, thank you.
Thank you very much.